Hello, this is Scholar Straff doing some math. Today we're going to be looking at areas of trapezoids, rhombuses, and kites. So let's start off with trapezoid. We have two bases and two legs. The bases are parallel, the legs are not. So let's call this base 1 and base 2. And then we have a height here. And that's a right angle. Okay. So the area, let's go ahead and label this B, E, F, D, C. So the area would be 1/2 times the height times the quantity of base 1 plus base 2. So that would be 1/2 the height. So in this case, it would be BF times the quantity base 1, which is ED, plus base 2, BC. So you add your bases together, you take half, and then times it by the height. So I want to rewrite this equation. I'm just going to rearrange things. This is 1/2 base 1 plus base 2 times height. Same thing, I just put the height on the outside. So either way works. But as long as you add the bases up first, then multiply the height, and then take half, or take half and multiply by the height. We'll do some examples. Area of a rhombus. So if we got a diamond looking thing here. So remember, all the sides are the same in a rhombus. Basically, the area of a rhombus is 1/2 diagonal 1 times diagonal 2. So let's call this C, B, D, E, B, C, D, E. So diagonal 1 would be, well, you can call it BD. Diagonal 2 would be CE. So my area would be 1/2 diagonal 1 times diagonal 2. Area of a kite, same way. So if we have a kite, so consecutive sides are the same, but not opposite sides. A, B, C, D. 1/2 AC times BD. Take the two diagonals, multiply them together, then take half. Alright, let's do some examples. Find the area of the trapezoid. So remember, area of a trapezoid is 1/2 base 1 plus base 2 times height. So area is 1/2 base 1, which is, now it doesn't matter which one's base 1, base 2. It's either the 8 or the 16. We'll be adding them together. Times height, which is 8 times the square root of 2. Okay, so area is 1/2 of 24 times 8 square roots of 2. So I have 12 times 8 times the square root of 2. And 12 times 8 is 96 square roots of 2. Alright, area of a rhombus. Alright, so 1/2 diagonal 1 times diagonal 2. So they say that this piece is 8, that means this piece is 8. If this piece is 11, then that piece is 11. So 1/2 of diagonal 1, which would be 8 plus 8, which is 16. Diagonal 2, 11 plus 11 is 22. Which will give me 8 times 22, which is 176 centimeters, or square centimeters. This last one would be square feet. Don't forget your units. Alright, let's do some more. Alright, we have a trapezoid. It's not a standard looking trapezoid, but it is a trapezoid nonetheless. This one gives us our height. So 1/2 base 1 plus base 2 times height. So 1/2 of 9 plus 7 times 4, which is 1/2 of 16 times 4, which is 8 times 4, which is 32 square feet. Oops. Part B. Okay. Area is 1/2 diagonal 1 times diagonal 2. Okay, area is 1/2 of 12 plus 12, which is 24. 18 plus 18 is 36. So I'll have area equals 12 times 36, which is 432, and then our units, square meters. Alright, example 3. One diagonal of a kite is twice as long as the other. The area of the kite is 56.25. What are the lengths of the diagonals? So, area of a kite is 1/2 diagonal 1 times diagonal 2. So the area is 56.25 equals 1/2 of x times 2x. So I'll have 56.25 equals 1/2 times 2 is 1. X times x is x squared. Take the square root of both sides, and we'll get x equals 7.5. So diagonal 1 will be 7.5 meters. And diagonal 2 is going to be 2 times that, so 15 meters. 2 times 7.5 is 15. Example 4, you have a scale diagram of your backyard. Each square on the scale diagram represents a 3 meter by 3 meter square in your yard. What is the area of your backyard? So each of these tick marks here, it represents 3. These are 3 by 3 squares. So the height of this trapezoid, 1, 2, 3, 4, 5, is 3 times 5, which is 15. Base 1 is 3, 6, 9. 3, 6, 9, 12, 15, 18, 21. So this whole piece here is 21. And now we have everything we need. Area of our trapezoid is equal to 1/2 base 1 plus base 2 times height. So 1/2 9 plus 21 times height, which is 15. So 1/2 of 30 times 15, we got 15 times 15, is 225 square meters. One diagonal of a kite is 3 times as long as the other diagonal. Okay, so if I measure this distance, let's call that x, and then the other diagonal will be 3 times that. The area is 73.5 yards, square yards. What is the length of each diagonal? Area is 1/2 diagonal 1 times diagonal 2. 73.5 is equal to 1/2 3x times x. Okay, so what I'm going to do is, instead of multiplying the 1/2 and 3, because that'll give me a fraction, I'm just going to multiply both sides by 2 to get rid of the half. So I have 2 times 73.5, the half goes away, and I'm left with 3x squared. This will change into 147 equals x squared, or 3x squared. Divide both sides by 3, and we'll get x squared equals 49. Take the square root of both sides. 7 times 7 is 49. So one diagonal is 7 yards. And diagonal 2 would be 3 times that, which is 21 yards. Checkpoint 3. Find the area of the rhombuses with vertices 2, 4. So we've got to graph these. 5, 6. 8, 4. Oops, what am I doing? Yeah, 5, 6. 8, 4. 5, 2. Boy, this is not a friendly one. Okay, we know that this is a rhombus. And if we have a rhombus, the area is diagonal 1 times diagonal 2, or 1/2 diagonal 1 times diagonal 2. So luckily, we can find the diagonals, and I'll use some colors. So let's call that diagonal 1. Diagonal 1, we can count to be 1, 2, 3, 4. Diagonal 2 is 1, 2, 3, 4, 5, 6. So now I can plug it in my formula here. Area is 1/2 4 times 6, which is 2 times 6, which is 12 units, square units. So hopefully this helped you out. Have a good day.